Right. So first we will discuss about the bike project, the bike rider project. This is the agenda for today. And the then we will talk about a new project, the audio cleanup project, whereby given a sound, we need to clean the audio, as in we need to clean the fillers, we need to clean the gaps, and we need to clean the noise. Okay, so I've got the pre-trained, again, this one is a supervised learning project. And then we'll talk about naive Bayes. Afterwards, we will talk about XGBoost, and then we will talk about basics of NLP if time permits. All right, the time series one, we will keep it some other time. Okay, so even though we will touch briefly here the time series one, but the time series is something which needs a complete session for itself. So, and even the NLP, we'll just touch upon the basics of NLP and get you started. The NLP part would at least require at least 3 sessions. Okay, so therefore we'll have to dedicate separate duration for these, and these parts are okay. So a question from Bintao is, I do not see audio cleaner project in the CloudX Lab because uh, it's not something which we have already done. It is still, we have recently received the data for this. So we'll be uploading it on one of the servers on the CloudX Lab, and then you will be able to see it there. All right. Okay, good question, Kamal. Will you be covering unsupervised learning algos anytime? Yeah, that's another thing that I keep missing all the time in this session. Unsupervised learning like K-means, and even the LDA is considered as unsupervised. And there are other hierarchical clustering, uh, hier- okay, hierarchical clustering or clustering, K-means clustering, or these. So we might have to see that how do we take about this, because this is something that we have not planned. And here, okay, so all right, so something, these 3 parts that we might have to take out extra sessions. So we'll take out extra sessions in order to cover these parts. So because they require their own treatment. All right. So where are we in the session? So we have covered most of it. Okay. So we have covered the introduction to Python, introduction to ML, then what we did end-to-end project. Then we learned classification, training models, right? Here we learned MNIST, here we learned gradient descent and other parts. Then here we learned about SVM, then decision trees, then ensemble learning, and then we learned about dimensionality reduction. This is where we will start from tomorrow. Okay, great, great. So there are few things that we need to discuss. So let's start first with the bikes project. Great. All right. So the bike project is the 4th one. The project is on the similar lines as the end-to-end project, just it has little more angles to it. Okay. So in this project, basically we are provided with the, should I zoom it? Oh, it's okay. Okay. So in this project, we are provided with this data set, bikes.csv. It's a standard UCI dataset from UCI. Okay. And it contains the hourly rental bike demand data. Okay. So there's a company which has bike demand data. They're renting out bike. And what you need to do is based on these parameters, you have to predict the the count of rental bikes. Okay, so these are the various parameters. The first one is instant record index. All right, instant record index, and this one is the date. This one is the season. Then the season is a number value, though it's a categorical variable. It has 1, 2, 3, 4. Okay, it's not a continuous variable. And also it's a ordinal, which means there is an order of these things. No. Season doesn't have ordinal. Okay, then there'll be month. There is a R, whether the day was holiday or not. There is a spelling mistake here. The weekday, whether which day of the week was it? Working day, if the day is neither weekday nor holiday. Okay. Oh, sorry. If the day is neither a weekend nor a holiday, otherwise 0. Okay. So then weather situation. Okay. Weather situation and yeah. Okay, weather situation is again 1, 2, 3, 4 values and so on. Okay, so these are the various parameters. Temperature, normalized temperature in Celsius. Then A temp is normalized feeling temperature in Celsius. Okay, these values are derived based on this. Okay, and then there is humidity, normalized humidity. Then there is wind speed. There is count of casual users and registered users, and the count of total. This is the target variable. All right. Okay. A question from Binta is, I cannot see the late topics in CloudX Lab. So we will have to plan where to add these topics, the one that we are going to discuss today. And specifically with naive Bayes and natural language processing, these two topics we might have to add. All right. So good. So coming back to the project, so in this project we'll be basically it's a standard project. We could actually do it exactly following the steps that we followed in end-to-end project. So in end-to-end project we followed a certain mechanism and certain steps. So we could actually follow the same one and get decent output. Okay, the project that you see here, there is a solution that we have provided. It's a partially completed solution, and this project, this wizard, it basically will guide you to fix this partially completed, a well-optimized solution. And by the way of prompting you to complete it, you will learn this particular project. Okay, there's strategies that are followed in this. Okay, so this way we will also have an surety that you have completed the assessment. Okay, so again the same thing, you see the entire notebook on the right hand side. It is partially completed notebook. Okay, this is partially completed notebook. And as you move ahead, okay, so yeah, we are going to explain those utility functions, Bintao. Good question. All right, the font is little tinier than, okay. I can't do much here because if I do that, then the right hand side will go. All right, so what you see is this is the main project. Then you go to the next one. Okay, so the first challenge it's asking me is, we will import these libraries into the environment. Okay, so as we go down, you see these libraries. Okay, here this was the task that you had to import OS. So I have already completed it. So I'll have to run it. Okay, I'll have to run it and then I'll click on I'm done. Okay, in case this does not work, right? In case this does not work, make sure to close your other Jupyter notebooks because it starts examining if there are other notebooks open, it might pick the other one. Okay, that's why you generally should close the other Jupyter notebooks. All right, so this way, so we have designed it this way that you should be able to fix the task and get it validated. Okay. Now, as we go ahead, which of the libraries can be used to scale the features quickly? Stand scaler, right? So, all right. So there'll be more tasks here. So it's saying that here are some of the utility functions. Okay. So here the utility function, as you can see, Binta, is set day df assigns day's name to each of the rows in the data set. Month CNT, count of the months from the start of the time series. Okay. And display the scores. Okay. Function used to calculate the mean and the deviation of observed scores from cross-validation of models. Okay, so here these are the functions which we, as per this is a pre-prepared project. So these functions have been already defined for you. Okay, they will be used at later point of time. Okay, okay. A question is, what does this mean? What does this part mean? And okay, so df.shape, and this is the number of rows in this um, this data frame, and we are multiplying d with this. Okay, and you can generally test it out what these things mean by, let's say, go to the point where the set date is being called. Okay, set date is being called, and add one more cell above it. Okay, so you could generally take a look at, this is the data frame, right? This is the data frame. So we are saying shape, right? And we are saying give us the 0th part of the shape. Okay. All right. Let me just load the data and then we can. All right. Let me go up. Yeah. I'll just show you this part. So let's say here, I want to test it out. What does it mean? Okay. So we could say shape, and so this is the kind of shape. And when I say 0, I'm going to get the first value, that's number of rows, as from the tuple, right? Good. So next thing is that we are multiplying this with this. What does it mean? It means d gets multiplied so many times, right? So you can see this is what happens when you multiply an array with a number. Okay. So I hope this is clear to you. So that's what is happening here. All right. So what we are doing is we are creating those many number of Ds. Okay. And so my first suggestion would be, okay, my first suggestion would be that you attempt this project instead of just following these guidelines. These are one particular solution by the one who won this competition. Okay, these are one particular solution by that. Now, you could actually come up with your own solution following the end-to-end project, just like we did earlier, that we will clean up the data, we'll remove we could actually follow the standard procedure, importing the libraries. This is something we'll do it later. And loading the data, cleaning the data, adding the derived features. These are the various derived features that they have added. You don't need to do this before. You did not need to do it. And these are something that are optimization. So you could actually observe the data first and see how it is going. And then maybe maybe based on your experience, like what kind of features do you want to add, you can do that. Okay, and then it's basically somebody else has already created this. So Prateek has done this, and I would suggest that instead of following this first, you follow your own strategy, the one that we followed in end-to-end project, and try to see the performance using without using this. Okay, without adding derived features. Okay, and split the data, train several models, fine tune them, and so on, right? So that's first is the first way. Second way, just follow through this wizard and observe their project. So here these are the extra functions that has been defined. This function is setting the for the for one particular column. It's basically from based on the weekday, it is setting the setting a new day of the week. Okay, that's what it is doing. So it's basically picking the weekday, then it's basically adding one more column. And how it's doing that, it's basically subtracting the day from the current day and adding 7 to it. Okay, and then divide by 7. So that way. Okay, so problem statement of the project is to find the, okay, let me just go back. Noor's question is, what is the problem statement of this project? Okay, so the problem statement is we have to predict counts. We have to build a model that can predict the count of rental bikes at a particular day in future based on other factors. Okay, if these other factors are given to you, you should be able to predict the counts of total bikes that will be rented that day. Okay, so that's what we need to correct. Thank you, Noor. It's a good idea that we should do ourselves without following the instructions so that we can compare where do we stand exactly. So ideally, that's the right way to do it. So this one is basically gives you a good enough one. So you can just click on hide playground and start following this. And okay, so the goal of the model is to estimate bike demand in future given the parameters as observed in the past. Okay, that is the main goal of the project. All right, so you can do that. Okay, so and once you're done with this, then you follow through this wizard. This wizard basically asks you to do various tasks and gives you various targets which you need to follow through. Along with that, it basically gives you quizzes and quizzes which you need to perform here. All right, great. So on the right, you see it's kind of a partially completed project. Okay, for me, since I have already completed parts of it, therefore it's a running code. For you, you might have to fill in these details. It'll keep on guiding you throughout. Okay, and like here you have to, okay, so you have to complete these statements. So it has various tasks. It is a partially completed code on the right hand side. Okay, it's a notebook which we have embedded in the browser. Okay, so I would say that first you create from the scratch. Okay, just follow along. Like take this project and go here in the Jupyter notebook, create your own notebook. Okay, and using Python, and then get started there by working through this one. All right. So, all right. A question from Kamal is, Can you quickly discuss the MCQ questions 24 to 26 in this one? All right. Okay. So yeah, these are based on, okay, a good question from Bintao. Question from Bintao is, are days and weekday keywords here? Not really. This weekday, you see, it's basically a column of this data frame. Okay. And days we have defined here, it's an array. Okay. All right. Is that your question, Bintao? All right. All right. A question from Kamal was that could we take a look at these questions? So let me just gain more context here. All right. So categorical encoder is like, you remember that one hot encoding where we needed to convert the categories into something, right? So we again have to look at what columns are there. Okay, what columns are there and what will be the best way to look at. Okay, so these are the columns, right? These are the columns. And do you think that is there a categorical variable? Okay, or let me just import the data. Take a look at the data. Okay, take a look at the data. Okay, this is my, okay, so let me just take a look at the data. Okay, so you can see that. So this is my data. Do you think that we need categorical encoder? When do we need categorical encoder? When we have a categorical variable and we need to convert, say, values into 1, 2, 3 instead of a string. And in case there is no order between in the categories, what we do then is we create one hot encoder, right? So question is, in this case, do we need a categorical encoder for any of the fields? Okay, so that you need to observe, figure out, and observe all the variables, understand that whether it is a categorical variable, but do we need to encode it again, because the value of weather situation is 1, 2, 3, and 4. Okay, so those kind of things you need to answer. All right, good. So 24th. All right. Now, next question is, what is the max value of X form work HR? So there is one particular, actually the name is actually weird. It means transform work hours. Transform working hours. That is what the variable name. Okay, so here here right now we have not added those extra columns. It'll ask you to add those extra columns as we go down. Okay, these are derived columns. Okay, and once we do that, I have already done it. Okay, and okay, so yeah, transform this column that has been added. What is the max value of this one? So you'll have to actually calculate max value. Only then you'll be able to answer this question. Okay. All right, let's just go ahead to 26. Do we need one hot encoder for this problem? Actually, hot encoder is that one hot encoder in which hot encoder is the general term. One hot encoder is the one in which we put one in those values where the value exists. So let's say there was a column whose value go from the, let's say there is a column whose value go from Kamal, Noor, and say SG. Okay, so there is this particular column. Okay, what do you say, assignee, right? Let's say there is a particular column whose names are these. Now in this, if you want to convert this into one hot encoding, you'll have to convert this into 3 columns. Okay, like this. All right, so in the first row, it'll be only Kamal, then Noor. Is that your question? Or, all right, this is one hot encoding. A question from Kamal is, I had a confusion whether season should be considered as ordinal and categorical. Let me see. I think for season, do we need to consider season 1, 2, 3? They come in a sequence, right? So I think you don't need to hot encode them. Okay. So it's a ordinal category. So I'm not sure if you need the numerical ones. Okay. Okay. I think that it is an ordinal category, so I don't think you would need a hot encoder for that. So in my opinion, it should be no. Yeah. All right. So I think that's the one. So for this, since I don't think they have a column for which we need to convert it into the categorical, like multiple columns. So I don't think that's required. All right. So a question from Kamal is weather situation. Actually, weather situation is also going from worst to best. If you go into the first one, good question actually. Okay, I too had the similar doubt. So weather situation is again going from clear to heavy rain. Okay, so it's actually again the ordinal. Okay, wonderful. Okay, so I hope you can go through the project and all right. So all these steps, so I'll just go over from the beginning towards the end. Towards the end, a very good question from. Okay, a very good question from Kamal. How do you decide something is ordinal? Okay. Um, a good question is how do you decide something which is ordinal? Generally, you will face this confusion all the time that whether something is ordinal or not. Okay, and the way it generally, you know, makes sense is, let's say you're given the values as 1, 2, 3, 4. Okay, so when the answer is 1.5, do you think it makes sense? Okay, is it somewhere between those two values? Okay, then if that 1.5 might make sense, some logical sense it might make, then that means that it is an ordinal variable. There's an order. Okay, all right. So that's kind of I mean, if let's say we are doing prediction and there is a value 1.5, would it make sense? Or 2.5 or 3, 3.5, that way. So is there a inherent order or not? Okay. Okay. A question from Kamal is it not better to do one hot encoding? Okay. I think it is better to do one hot encoding in case of confusion. Yes. and you should give it a try, this project, with with both the things, and see which one is giving you, making more sense. Okay. All right. In certain cases, specifically the season is one classic example where the seasons have their own behavior, and instead of, let's say, considering that an ordinal variable, you could give it a try by considering that, making a hot vector, hot encoder over that. Okay. Yes. Answer to most questions is just give it a try. Okay. Yes. All right. So good, good. All right. So one more thing is, let me just walk over this code, and then I think that'll be better. Let me see if I can zoom the. Okay. All right. I think I can open the same Jupyter notebook by going to my home folder. This is my home folder. Okay. You will notice that there is, by default, there is this CloudX Lab Jupyter notebooks. You can actually open the same one there. Okay. All right. So this way you can zoom it and things like that. Okay. Good. All right. And okay. Good. Good. So Kamal's question, Kamal's point is, no, life does not give you many chances to try. So you need to, okay. Um, all right. It's an interesting debate, and I would still go with the give it a try kind of model, even with the life. And it doesn't give you many infinite possibilities, but it does give you many attempts. Okay. Like you can play cricket many times, correct? Or you can hit a bat, or you can throw a ball multiple times. So yeah, it does give you a chance. Constraint some more, yes. Good, good. All right, all right. Now, I was going to take you over this solution very quickly. So here there is one part that will be a little confusing to you, and that part I would clarify. One is these utility functions. You will have to go through these utility functions in order to understand stepwise. Try to break it down into parts. Try to call this on your bike's data below as you create your data frame. And yes, then we go over the month counts and display score. All right. So good question from Bintao is, what is ITER tools? ITER tools is actually quite useful library. We must have used it using the using while discussing the NumPy and other Python tools. Okay, so yes, it's a very good question that it has come up. So ITER tools gives you these powerful tools for iterating. And things like Cartesian product, you can do by yourself. Let's say you want to generate, um, let's say, all permutations of A, B, C, D, and X, Y. You could just use ITER tool for this. Okay. And you could also generate this kind of tool. So the funny thing happened was that I was taking interview and I asked somebody to actually write this code. Okay. And this is exactly the question was. So all he did was he just said that we will import iter tool and then we call this method. Okay, so apparently in iter tools, for almost every permutation, combination, or iteration, you will find the solutions to it. Okay, And yeah, so basically it's worth looking at it. It saves a lot of time, and some of the algorithms are hard to code, like for example generating all permutations of these strings. Okay, so or generating a permutation of these array. Okay, so that way you should be able to I mean, of course it is important to know how to code, but uh, getting it done quickly is a better idea. So it's better to go over these libraries. Okay, just take a look at these functions. All right. So you can generate permutations, you can cross do a NC2 like that combinations if you want to just pick up two values from this, and there's combinations with replacement and so on. Okay. So you just go over this. This is going to be quite useful to you, specifically these methods that you'll notice. While these are more of useful when it comes to our kind of work, like machine learning kind of work. Okay, let me turn off my phone. All right, great. I think yeah, this is a good thing that you asked the question. So go over this. I think once you are familiar with this, try it out, then you will be able to recall when it's required. Okay, so to improve your recall rate, just go over these ones. All right, it's not still turned off. Let me just turn off my phone properly. Okay, great. I'll just give you the link. Wonderful, wonderful question. So moving ahead. All right. Okay. Oh, I shared only with the good. Great. Now moving ahead. Where were we? Yeah, this one we were talking about. Okay. So next step is to load the data. This is the data. Here is the file path. This is we are using read CSV to load it. And once we are done with that, then we are just checking the information inside the data. Next we are doing is here, we are dropping some of the columns. Okay. Then we are adding some derived variables. Okay. These are various derived variables that we are adding. This would require some amount of effort from your side. Even if you don't, if you are creating your own project, do it without adding these derived variables. That'll be good. Now, this is an important part. This is an important part, and we sometimes call it basically a time series part. Okay. So a question from Pintao is that can you explain adding derived features to transform your data? Okay, should I go over this? So basically here we are adding. Okay, so here these are the various columns the author has added. Okay, so after researching, after thinking through, after realizing that the total day count from the beginning till it matters. So he has figured out that these are the columns that could be of use. Exactly the way in case of end-to-end project we had added In case of end-to-end project, we had added one of the one columns extra into the data frame, right? In the same way, the author has added these 6 columns. Okay. Now, all right. So these are the 6 columns. Now, next, moving ahead. So I'll just talk about this part. Rest is obvious to all of you. Okay. This part, what it is doing is that since the author has figured out that the data has trend in it, as in it's an important part. So let me just go over it. So let's say at every year, Amazon needs to prepare. Every year at Amazon, we need to prepare for say Christmas and Black Friday. Okay, so what we do is on those to give out those to be ready for that amount of traffic, we need to be able to precisely predict the traffic, correct? And to be able to precisely predict the traffic, we need to know a lot of variables. Okay, now what we observed at Amazon is that even if we don't do anything, since the world population is increasing and the internet adoption is increasing, therefore there is a natural tendency of total number of traffic to increase. Okay, even if we did not put any extra effort, that traffic would increase naturally. Okay, so that's why that factor of trend you need to take out. Okay, that factor of trend that you need to take out. So what it does is it's doing the machine learning first only on one column, one feature called day count. How many days have passed since the day 0 of this data frame, this data? Okay, so basically the counts that you see is, so here capital X has only one column called day count. Okay, Y has only one variable called CNT, which is counts of the bikes that went. So it is trying to figure out a correlation between days and the counts. Okay, using the linear regression, it is fitting this one, and then it's fitting this one. Okay, and then and then subtracting this value, this this predicted value from the actual. Okay, from the actual counts. Okay, so these are the predicted value just based on the counts, and then we are subtracting those values. Okay, this is one vector, this is another vector, or you can say series, or I think will be data frame. So when we are subtracting these two, we are subtracting one series from another, and we are getting another column that we have added. Okay, so you can see that we basically are removing the impact of days count from the overall count. Does it make sense? All right. So this is one part, then rest of the things are okay. We analyze the data, we visualize it, we take a look at it, and then we do other parts like find the correlation between the fields, and then we take a look at, okay, and so on. Okay, so and then we try to represent the data and so on. Okay, then we do the box plot, the ones that we discussed earlier, and then we divide the data into training set and so on. So then we basically try these 3 models. Okay, we try these 3 models, and yeah, I have tried one more from my side, the one that is we are going to discuss today. And then we visualize the outcome, then we fine tune using grid search, and then okay, Then what we're doing here, then we are evaluating. Okay, then we are evaluating further our model. Okay, and that's pretty much. All right. Now here, this last one is actually in the beginning we are adding some columns, right? Ideally, we could have done the this way. Okay, this is not complete, but you could design your code such that you are having the attribute adder in the pipeline itself. Okay, so you could take a bit of inspiration from this. That's pretty much. A question from Noor is, there is a built-in feature. It's a very good question. Thank you, Noor. Question is that in the data frame, why there is a built-in feature to get the correlation, right? Like CORR, the one that we are using here at this point, correct? This is the one you're talking about, right? So, right? So, so the thing is that we want to remove the impact of the trend. Okay, we want to remove the impact of the trend. As you can see that this was the trend, right? Based on the day count, these were the count values predicted. Okay, this was the trend. So we subtracted this trend from this overall value and we got this everywhere. Okay, so even though we can just find the correlation using the correlation feature of that data frame, but here what we are doing is we are completely removing the impact of the fashion or impact of the trend. Okay, all right. Okay, all right. So okay. Yeah. Question from Noor is, but why do we need to remove the impact of a trend? What is the need? We did not do this in end-to-end project. Correct. Correct. So it's kind of an extra optimization. So the uh, basically the in the data, the most of it basically should be figured out by our regression tools. Okay. So most of it should be figured out by the regression tools, that there is an additional dependency on time since the beginning and so on, and should be automatically added. We generally do not need to do this, but it's an extra step the author has done in this case to optimize it further. And but even if you don't do this, you will get decent results. Okay. Okay. Yeah. Great. 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 So I think, yeah, I think you got the answer. There's a question from Bintao. Based on the hint of task one, I'll just close this one because it'll have two things opened. Okay. Question is, based on the hint for the task, I define test X tools. Okay, number 50 in the project. Let me just take a look at number 50 in the project. Okay, number 50, I think for me it is going to be different. All right, let me just search for this particular variable. All right, this one, right? Okay, so here it says that task one, uh, which one is it? Define test columns. Okay, let me just find. Actually, I've changed the entire sheet, so that's one of the differences. Okay. Yeah. Can I just take a look at yours? You could share the screen and then we can discuss. All right. So I think okay. I've stopped sharing my screen, so you could go ahead because I've changed my this one a lot. Okay. I've already completed. Okay. You mean the quiz question? Okay. So okay, quiz question 50. Okay. All right. So oh, I see. Based on the hint of task one, define test one and okay. Okay, let me take a look. Right. So this is the, yeah. Okay, so just do shift enter. Okay. Okay. Yeah. One more thing I would like to know is text as x underscore columns is not defined correctly. I see. I see. Let me just try myself and then can you just show me, can you scroll up? Can you scroll up on the left hand side? Left hand side. Yeah. This one is last one, correct? Okay. Yeah. Oh, I think x test equals this. All right. All right. No worries. No worries. I'll take a look at it. I think maybe there is a mistake in this because it should not test x columns, correct? It should be testing either capital X test, Y test, or test set and MSI. Okay, so I'll take a look at it. All right. I think there is a mistake in that part. All right. So let me just take a look at the test cases. Yeah, it's testing X columns, Y columns, and this and this. Okay. So here it should be testing capital X and these things, right? That's one of the reasons. All right, X form HR. And this test is different. Yeah, you can see it's actually, yeah, the assessment is wrong. Okay, so we will have to fix it. All right, so let me just put it in on my to-do. Fix the 50 question. And okay, good. All right, so let me save the notes. Okay. Okay, great, great. So that was an overview of the project. Let's continue to our next topic. Okay, so all right, great, great. All right, so should we start with naive Bayes, one of the classifiers? Great. So, all right. So naive Bayes, or sometimes we call it stupid Bayes, is a classification technique based on Bayes' theorem. It has a naive assumption that the predictors, the features of instance, are independent of each other. It's extremely easy to build, and it's very useful, specifically if you have humongous data sets or large data sets, right? It's known to perform even highly sophisticated classification methods. And these are basically earlier methods before the new generation of machine learning. The naive Bayes was quite popular when it came to the text processing. Okay, when it came to text processing, people used to use naive Bayes. Though newer techniques and newer statistical techniques um, have are more useful. The ones that we have discussed already in the class, those techniques are far more powerful and useful. But sometimes you don't need that much powerful technique. Sometimes when the data is humongous and you want to do a quick analysis, you might want to take a look at naive Bayes. Okay, so the Bayes theorem is actually something that we study in case of probabilities, right? So here, the way we define the Bayes theorem says that the posterior probability, meaning here we are saying that the probability of C happening once X has happened, probability of C happening once X has happened is equal to this probability multiplied by this probability divided by this probability. Okay, so this probability is the likelihood of X happening once C has happened, okay, multiplied with probability of C multiplied with probability of X. Let me just share the slides. Okay, let me just share the slides before I jump further. Okay, great, great. So this is what it is, and based on this is basically a standard definition of the posterior probability as defined by Bayes theorem. Okay, so this formula is what we are going to use. So if we know that the probability of X happening once C has happened is this, we can predict the probability of C happening once S has happened. Okay, so this is exactly what we do in case of, say, normal machine learning. We have instances, training set, based on which we we learn and then we predict, right? So here, if you think of X as your normal instance, the features of instance, okay, imagine that X is, this could further be converted into far more. If you have many events happening, like capital X is a bunch of events, X1, X2, X3, you could also define in the same way. You could say probability of C happening once S has happened. You can think of it like hap happening on the test data set, okay, is proportional to or equal to the probability of X1 happening once C has happened, basically from the training sets, multiplied with X2, the probability of X2, posterior probability of X2, X3 up to Xn, multiplied by probability of C. Here we are assuming that we are not dividing by Px because the overall probability of capital X could be 1. Okay, so that way. So, all right, so does it make sense to you? Now, I think a better way to answer this question, as in explain this Bayes theorem or this formula, would be by taking an example. Okay, Let's take an example of this. Imagine that we have this weather data, okay, and whether the players like to play that day or not. Okay, so when the weather was sunny, they did not play. When weather was overcast, they played, and so on. So this is the weather condition, and this is the play. This is whether the players played or not, or game was played or not. Now, what we need to do is now reverse. This is the data that's given to us. Now, we got the probabilities here. Now, what we need to do is, given a weather data, we need to predict whether the players would like to play or not. What is the probability the game will happen? Okay. Now, the first step in case of naive Bayes is preparing these frequency tables. This is basically the model. Okay, so we are preparing the frequency tables. Here we are saying that we're putting one table is here, where we are saying whether is this and whether game happened or not. So overcast, if the weather was overcast, how many yes? How many yes? Overcast 1, 2, 3, and 4. 4 was yes, and there were 0 no's. Okay. Rainy, if the weather was rainy, how many yes are there? Okay. How many yes are there? 3. Sorry, 2 are yes and 3 is no. Okay. So we prepare, the first step is preparing these frequency tables. If we had multiple columns here, we'll prepare multiple frequency table with respect to each feature. Okay, we'll talk about that one very soon. Let's focus on this one. Okay, let's focus on this one. So here what we are doing is we're preparing the frequency table out of this table, and this frequency table contains these columns. Okay, and right. So here the overall probability of game happening is 9 by 14, correct? And the probability of game not happening is 5 by 14. Why? Because 5 plus 9 is 14. So, okay. So 5 by 14, 9 by 14. Now, the probability of game happening, okay, and weather being overcast is this 4 by 14, right? And so on. So, so sorry, the probability of overcast is 4 by 14, rainy is 5 by 14, sunny is 5 by 14. Okay, I hope these probabilities are clear. Yes, Balaji, Bintao, Gigi, Kamal, Shahrukh, Noor, Pavan, and Ross. Okay, all right. Now, now let's see what we are trying to predict. We are trying to predict that will players play if weather is sunny? Okay, will players play if weather is sunny? Now, we are going to use the same formula. Will, what is the probability of yes if weather is sunny? Given the weather is sunny, what is the probability of yes? It's equal to probability of sunny when they said yes, when the players played, multiplied by probability of yes, divided by probability of sunny. That's the formula that we have discussed just now, the Bayes theorem. Then what we have is here is the probability of sunny when the players played is 3 by 9. Why? Okay, you can see uh, here. Mm, okay, so sunny and yes, sunny and yes. So 3 by 9 out of total 9 times yes, we got 3 by 9, right? 3 out of 9. So that's 0.33. Okay. And just sunny. What is the probability of sunny? 5 by 14. Correct? What is the probability of yes? What is the probability of yes? It's 9 by 14. Correct? So we got these values. Now if we put them, the probability of playing is zero point 0.6. Okay, probability of playing is zero point 0.6. We can also compute the probability of no in the same way. What is the probability of no? The probability of no is in the same way 0.40. Okay, so I'll just put low here. It's not high. Okay, so all right. Is it clear? So probability of playing a game is zero point 0.6 if the weather is sunny, and probability of not playing the game if the weather is sunny is 0.4. Okay. All right. Yes, this is quite useful and quite fast. Even we can do it with on paper, pen and paper for good enough data. And the only problem with this is that if you have multiple features, there is no interdependency between the features. Okay. Yes. Let's try to stretch it. A good question, Noor. So let's try to stretch it for uh, multiple features. Now, same game could be a function of the outlook of the weather, okay, temperature, humidity, and windy. Okay, so let's say this is the table that is given to us, that if the outlook of the weather was rainy, temperature was hot, humidity was high, and the windy was false, as in there was no, it wasn't windy, then the game was not played. Similarly, we are given other data. Now, problem statement is that on a rainy, mild temperature and normal humidity and a windy day, will game happen or not? Will game happen or not? What is the probability of game happening, right? So we prepare this frequency table. Okay, for each of these features, what we just saw, each of these features, we prepare the frequency table. Here you can see clearly that we are considering every feature as independent. Every feature as independent of other. So we are trying to compute the frequency of because compute the probability because of every feature, and then we are going to multiply all of that. Okay, so here we prepared a similar table that for sunny, overcast, and rainy, how many times the game was played and how many times game was cancelled. And similarly, the for humidity, for high and normal, what are the times that we played the game and we did not, and so on, right? We did it for temperature, we do it for the windy. Okay, now the next step is let's try to predict this. Okay, to predict this, we will have to compute the likelihood of right. So we have to, what are the likelihood of yes if the outlook was rainy, and we said, so we are using the same formula. Okay, we are using the same formula, the one that you see at the bottom of this diagram. So here, this is the formula that we are going to use. Okay. Okay. This is the formula that we are going to use. And all right. Great. Now, okay. Okay. A question from Kamal is, why is P yes sunny can be directly stated as 3 by 5 referring to frequency tables? Okay. Why yes and sunny is 3 by 9, right? 3 by 5, that's what you're saying from here. Okay. Question is, what does this frequency table represents? This frequency table represents that when it was sunny, how many times, when it was yes, sorry, when it was sunny, how many times we said yes and no? Okay. So out of 5, we had said yes if it was sunny. Okay. So we know that when it was sunny, that what is the probability of this one? Now we are computing the reverse. Okay. We are saying that we are computing the reverse in the sense that will it be yes if the weather is sunny? Okay. Okay. Or you can say yes. The frequency is 3 by 5, you could say. Yes. Okay. All right. So basically, it's the extension of the same mechanism as we saw before. Okay. The same, although you can compute the same probability by multiple means. Okay. And the idea is to basically formalize the same process, even if there are many columns, many variables, and so on. Okay. Right. All right. So yes. So here you can see that it is 3 by 5. So uh, theoretically, yes, it's the same answer. It's the same answer. But if we need to kind of, if we have multiple values, multiple variables, then it would be hard to use the same kind of deduction. All right. Good. Good point. Should we, yeah. Did I make sense, Kamal? No. All right. Okay. All right. So a question from Kamal is, even though we could compute it using the standard, just looking at the frequency table, the answer is that we're trying to formalize it so that we can use it over multiple columns and multiple values. Okay. Though you can generally deduce it based on this table itself, that what is the probability of yes. Okay. So let's go ahead. All right, wonderful, wonderful. Now, let's say we had multiple columns and we are trying to figure this out. So again, we're using the same formula in the beginning this time. Okay, we are saying what is the likelihood of yes given all of this? Given outlook as rainy, temperature is mild, humidity is normal, wind is true, and so on. Now, so what is the likelihood of saying yes? So we do the reverse. We say that what is the probability of outlook being rainy when it was yes? Outlook being rainy when it was yes. Outlook being rainy when it was yes. It is 2.2 by 9, right? What is the probability of temperature being mild when it was yes, temperature being mild when it was yes, okay, 4 by 9, 4 by 9, okay, all right. Temperature being mild when it was yes, okay, so therefore 4 by sum of this, okay. Humidity being normal when it was yes, humidity being normal when it was yes. Yes as in this is 6 by 9, all right. windy equals true, windy equals true. Okay, when it was yes, so it is 3 by 9, correct? And then multiplied by probability of yes. Multiplied by probability of yes. What is the probability of yes? Let's go back. In this diagram, what is the probability of yes overall? The probability of yes is how much? How many times did it occur? It 1, 2, 3, 4, 5, 6, 7, 8, 9, 9 by 14. Okay, 9 by 14. So this is the overall likelihood. All right. In the similar way, we could also compute the likelihood of no. Okay, likelihood of no is coming out to be closer to the same one. Okay, it is coming out to be 0.0103. So now we have a close answer here. So the answer is 0.0141. Okay, these are the chances of yes. Okay, now you compare the probability of yes and no. You take the one which is bigger. Okay, you take which is bigger. Also, what you do is you generally here since we have not normalized it. So here we can actually normalize it by just dividing by sum of the two. Okay, so now you can see that after normalization, this is 0.58 is the outcome. All right. All right. So one more thing I would like to say is here in this formula that you see here, the probability is here in this is the one that we used in case of multiple features. In that case, this is supposed to be proportional as per my understanding because we have taken out the denominator because denominator is same. If we are computing the probability of given x, probability of C1, C2, C3, then x is same. So probability of x, we don't have to worry. That's why it should be proportional instead of it being equal. Okay. So because we have not divided by p probability of capital X. All right. Okay. So we have not divided it by probability of this circumstance. Okay. Therefore, we need to normalize it. All right. Because the probability of this circumstance happening is itself low. That's why when you divide it by that number, it's going to be it's going to be a bigger one. All right. And how bigger? That you can see by normalization. Okay. So because denominator is same in both the cases, the probability of capital X, that's why we have not done that. Yeah. Okay. That's one of the reasons. All right. So yeah, one. So this was the naive Bayes algorithm, right? Now, does it make sense to you? So we were successfully able to predict the values. We were able to successfully able to predict whether game would happen or not happen given various parameters. All right, given various parameters. Now, an interesting question is that let's say we are we let's say there was one field called overcast. Let's say one of the questions was, what are the chances that game would happen if overcast is outlook is overcast instead of rainy, it is overcast. Now suddenly when either of the parameters that are to be multiplied, if these either of these are zero, what would happen is the entire probability will become zero, right? Entire probability will become zero because one of the field is zero. Okay, so how do we overcome this? This is called zero frequency problem. So how do we overcome them? That we simply you add 1 to all of the counts. So in this frequency table that we prepared earlier, in this frequency table, we'll just add 1 to all of the values. So there is no zero. And this is also called Laplace smoothing. You can take a look at, uh, keep in mind that Laplace smoothing is not as Laplace smoother. Okay, there are multiple terms in the same way. So keep in mind that it should be Laplace smoothing, or we call it additive smoothing. Okay, here we have just added one. In more general form, we can add alpha. Alpha is an integer, and that's how we do the computation. Okay. All right, let's take a look at if we can use the Jupyter, as in the scikit-learn for doing the naive Bayes. Okay, so here we go. All right, all of you, you can open the Jupyter, the same notebook. You can pull the repository. Okay. Okay. So can pull the repository, go to ML, go to machine learning, and say git pull origin master. Okay, so everything is already up to date for me. You can also pull. And once you have pulled the repository and you go to ML machine learning, you'll notice a new Jupyter notebook. It's called, okay, it's called naivebase.ipnb. Okay, all right. Now, this is the one you can use. Okay, so here what we have is, let's say this is our data. Okay, so this is X, this is Y, sorry, this is X1, X2, X1, X2, X1, X2. So these are the various features. These are the various features of your input. Okay, so this is first instance, this is second instance, and so on, right? And these are Y, as in the target variables. So we are saying model equals Gaussian NB, and we are importing it from naive Bayes. Okay, and then once we're done with that, we are simply calling fit, and we are predicting the values. Okay, so here we are just trying to predict for these. For 1, 2, it's coming out to be 3. We have already an input case, which is 3. That's good. And for 3, 4, do we have an input case? No. So for 3, 4, which one it would be like? Okay, it's coming out to be 4 in case of 3, 4. All right. So you can see that these are the predicted values. All right. So are you able to run it? This is a very interesting question from Kamal. Question is, question is, uh, okay. So question is, for Outlook Rainy, Okay, let me just take a case here. For outlook rainy, temperature mild. For outlook rainy, temperature mild. Okay, let me just take it there. Okay, so this is the one that we are talking about. Okay, for outlook rainy, okay, temperature mild, humidity normal, and windy equal. So I'll have to see outlook rainy. Okay, temperature mild. Do I have rainy and mild? Yeah, here. Okay, humidity normal and windy equals to true. The answer is yes. Okay, yeah, that's good. Yeah, so we could actually, yeah, we could have just recalled exactly, right? But here that's the important part. So it's just remembering the frequencies instead of the entire matching. Okay, so yes, it's not that bad after all. Okay, a question from Noor is why we have negative values in this. This is basically just like saying weather equals to sunny. Okay, so it's not frequency, it's the actual value. Okay, we are saying weather instead of saying sunny, we are saying weather equals -3. Okay, all right. So it could be anything. All right. Let's say had it been a temperature, it'll become -3 temperature, temperature 1 degree, 1 degree, -2, and so on. So it's completely okay. So this naive Bayes is generally okay or good for say where we essentially do the frequency counting. Okay, not for regression kind of a task. Okay, not for regression kind of a task. Now the next thing is the iris dataset. Let's take a look at the iris dataset. You remember the iris dataset? So we basically on the iris data and iris target, what we are doing is we are first training the Gaussian naive Bayes, and we are training it on this. And then once we have trained it, we are calling predict on it. Okay. So after prediction, we are just finding how many targets were not matching with the predict. Okay. And we are finding the sum of these zeros and ones. Okay. So here you can see that out of total 150 points, it's able to predict 6. It's able to predict 6. Sorry, it is able to predict except 6. All of the things are predicted well. So only mistake it has done on 6 because that's where the target is not matching with the predicted value. So it has mislabeled only 6 points. Let's just show you. So you can see that. Okay, and extremely fast. So Pawan's question is, Gaussian naive Bayes and naive Bayes are same. So Gaussian naive Bayes is essentially one of the implementations of naive Bayes. One of the implementations of naive Bayes. Okay. So yeah. So Gaussian naive Bayes is the basic one. There are two more. Okay. We'll talk about those. So all right. Let's just check the accuracy score using our same classification function called accuracy score we used for out of matrices. And so you can see the accuracy for the iris dataset is around 96%. Okay. So even though it's basically standard probability computation, we are doing a reverse computation that if this happens, then these were the chances. What are the chances of this happening based on the previous chances? So those kind of ba- based on independent factors, we basically try to compute the frequency. Okay, so you can see that it's actually, even though it looks like a very naive method, a very stupid method, but it does work in many cases. Okay, so it can serve as your first thing in case of humongous data, because this one does not. It's basically ON. The complexity is ON, and it doesn't have to go. I mean, it doesn't have to retain the data in the memory too much. It just need to retain the frequencies. Okay, so from that perspective, naive Bayes is really efficient, probably most efficient out of all the classification algorithms. Okay, now the next one is the we have some more example. If we were doing some random split, I just did a random split here. So I did some permutation and then did the same thing what we did above, just to compare the test. So 100 we capped for, okay. So 100 we capped for the training and 50 we capped for testing. So after we did this, the the performance was this much. Okay. It's basically because of the random state. Okay. Can we pass random state here? Random state equals 42. It doesn't have, so does NP random takes care of the random state? I think there was a function that NP dot random state. Okay, so there would be a NP dot random state, right? We used to set. Never mind, so we'll do that later. Okay, so we'll just say numpy dot random state. Okay, it's used by who all? It's used by permutation also. Cool. So we can use this is the one that we used earlier also. Okay. So you could just say random state equals 42 so that every time we run, it should not generate the. Okay. All right. Wow. No, it's still not following that one. Okay. I think this is the way we call it. Okay. Never mind. So we'll take a look at it later. How to specify a random seed for this. Never mind. So let's move ahead. So you can see that on an average, we are getting really good performance, which is close to 95. Okay. All right. Now here is the very simple example of sunny, overcast, rainy, and again sunny. So we have just created this, and there is something called label binarizer. So, okay, just like when we have one hot encoder, we can use label binarizer for encoding and then use that. Okay. Abhinav's question is, can we specify random seed while splitting the training and testing? Yes, of course. So ideally, we should have used the standard training, the standard function from the NumPy library, but here we are using we are just created our own splitting mechanism, and that's why we don't have that seed one. We are just using this random permutation. Okay, good question. So next is in case we have our data in this form, like the one that we solved earlier, we have our X as sunny, overcast, rainy, and sunny, and basically the categorical variables we have. So we could use the label binarizer, and that would essentially convert this into one hot encoder, just like this one. You can see. Okay, all right. And then once we have done that, we have transformed our data from categorical variables into numerical one. Then we can use the Gaussian, the same, the Gaussian naive Bayes to predict our values. So we could train it and predict it. So this is where we are training it. Okay, and now what is the error here? So we are saying x1, and okay, so we trained it and then it's able to give us the result. So this is how we do that with respect to the categorical variables. All right. So all we did was first defined x and y. Then we used label binarizer to convert our x into one hot encoders. Like okay, so let me explain what does it mean. So sunny, let's say it has given the name to sunny as 1. So 0, 0, 1. Overcast could be 1. If you want to know what names it has given, we can take a look at the classes, enc.classes. So overcast is 0, rainy is 1, sunny as sorry, overcast is the first column, rainy is second, and sunny is third column. Okay, so in first case, since sunny is true, this is the first instance. Okay, so here the sunny is 1, right? Sunny is 1. Overcast is 0 at 0th position. Okay, while okay, the rainy is on second position, so you can see, and sunny is again this one. So let's convert a single column into 3 columns by putting tick marks in that column where that value is true. Okay, so that's what the label binarizer does, and you can use label binarizer in conjunction with Gaussian in order to do the predictions on categorical variables. Okay. All right, so there are a few more things to talk about in case of naive Bayes. Okay, so we have done this. All right. A question from Noor is, can you please explain predict here? Okay, let me do that again. Good. So here what we are doing is we have just created, we want to see that on, what is second value here? What is second value? Or we can also do this, we can also transform using the same pipeline, right? So we are saying on a rainy day, what are the chances of playing the game, right? So it says that 0. That means it is, the game will not be played, okay, for this kind of data. So if we say, what is the chances of game being played if it is sunny? If it is sunny, then what is the chances? So let's just do one more prediction. Okay, sunny is which column? The last one. So answer is yes. All right. So this way we could experiment with these variables. So let's say we had in one of the overcast cases, let's say we had one more overcast case here. In one of the cases it was 0, and in one of the cases it was 1. Let's see in these cases, what happens when we train the classifier? Okay, so these are okay, good. Now, in case of overcast, what is the probability of overcast? Overcast being first one 1, last one 0. So the probability is 0. Okay, so that's how it is working. So maybe it has done the computation. All right, so yeah, a question from Noor is, can you please other Sunny as no? Okay, Sunny as no. Okay, so what if we have Sunny as no? I think it's going to use the same formula that we used earlier and predict whether it will happen or not happen. Okay, so in case of this is what? This is, let me just write it here. This is rainy, right? And this is sunny, and this is overcast. All right, great. So you can see the, all right. So actually, yeah, we'll have to we'll have to see that. Basically, it's doing the frequency computation and giving the result as yes or no. All right. Does it have a predict prob? Does it have a probe method? Yeah. Okay. This is the kind of probabilities that is coming out in case of overcast. All right. All right. So I'm back. Should we start now? Great. Great. So here we go. Using naive Bayes method, we can actually do a prediction just based on the based on the probabilities and frequency computation. Okay, so scikit-learn provides you the methods like Gaussian NB. Then here is again, if the continuous features do not have normal distribution, this is another thing that you should keep in mind. Most of the naturally occurring events have the normal distribution, normal as in the frequencies of the 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 frequencies of average things is at high. Average normal distribution is basically the bell curve. Okay, so if your continuous features do not have normal distribution, you should use some kind of a transformation to compute a normal distribution. Okay, compute to prepare a normal distribution. The if the test data set has zero frequency issue, use the Laplace smoothing. Okay, and you can remove the correlated features, because if you have highly correlated features, the naive Bayes does not perform very well. Okay, so so you should avoid the you should not, first not use the naive Bayes on the data where you know for sure that the features are correlated. The change in one feature impacts the other feature. though not in obvious ways. So in those cases, the naive Bayes does not perform well because basically change in one would impact the other, and hence the frequency computation will be twice and so on, and therefore it won't work. The with respect to the performance tuning, with respect to performance tuning or hyperparameter optimization, naive Bayes classifier does not have any or much scope there, because there is only one parameter, which is that the one hot encoder one, that is not one sorry, it's basically adding of one to all, that the Laplace smoothing one. So in Laplace smoothing we generally add one to all the values, but sometimes we can add some other value. So that's the only parameter tuning we have, and it can't be ensembled because ensembling essentially removes the variance. Correct? When you have many classification algorithms performing in parallel, the overall idea of ensembling is to remove the variance, all right, and improve the performance by removing the variance. And here there is no variance as such, and hence it would not make uh, any sense to basically ensemble naive Bayes. Okay, because um, or you can say, you can look at it this way, that all of the algorithms, you remember when we were talking about ensembling, that voting makes only sense whether soft or hard. Voting only made sense when there was uh, what do you say, there was difference from one classifier to another classifier. If there are many classifier all giving exactly same answer, then ensembling is not really the right choice. Okay, so diversity between multiple instances is not there. Okay, and also even if we create the variance by say doing the random sampling of the data, then also the naive Bayes doesn't make much sense, because at the end of the day, it's a very deterministic probabilistic model. Deterministic in the sense that every time you run this model on the data, no matter what are the input parameters, you're going to get the same result. All right. So those are the reasons why it doesn't make sense to ensemble the naive Bayes model. Okay, there are some variants in case of scikit-learn. Scikit-learn has three basic implementation. First one is Gaussian, the one which we are using. It is for the cases when the data has normal distribution. Then multinomial distribution, if it is used for discrete counts. Okay, and it is good for the cases where the data has multinomial distribution. Okay, multinomial as in it has multiple peaks. Okay, and it is one of the two classic naive Bayes variants used in text classification. Then third implementation is Bernoulli's, specifically uh, the okay, so this is good for the zeros and ones, specifically with respect to the one hot encoding. So when it comes to word embedding, or we want to do prediction on the words in a text, we can use Bernoulli. Again, there are better techniques for even the word embedding or word occurrence. In one of them is TF-IDF. But if we get a chance today, we will talk about TF-IDF, which is a better application than Bernoulli. Okay, so in general, there are good alternatives available for naive Bayes, but for performance reasons or for pre-processing our data, we sometimes want to use naive Bayes. Okay, specifically for the cases where frequency computation is something that we could use quickly to analyze our data. There are many applications. One is real-time prediction because naive Bayes is really fast and is eager learner, and therefore the predictions are really fast. Second is the multi-class predictions. It is known for multi-class prediction feature. It has been used in history in text classification, spam filtering, sentiment analysis, mostly for text classification. Okay, so it has a higher success rate as compared to the other algorithms, and it has been widely used in spam filtering in past and sentiment analysis. Also, one thing that I would like to be very clear is that naive Bayes classifier is quite often used with recommendation systems. Okay, recommendation systems, and the kind of most of the collaborative filtering or recommendation system, they're the same name for uh, recommendation systems are also called collaborative filtering. So naive Bayes classifier is generally used in conjunction with the collaborative filtering. And again, this is something, okay. So these are, okay. All right. So we had not planned for the recommender, as in we have not have these things in our subject, but machine learning is really, really big area. So you can't really cover everything in machine learning. And but let's see if we can have a separate session for collaborative filtering. Collaborative filtering is, there has been quite a few research in collaborative filtering domain, and we can we can maybe keep a separate session, go over all algorithms, go over all libraries like on big data, small data, and like that. So we could actually plan one recommendation. Okay. All right. A question from Ross is add to the additive regression. Okay, you mean that we should cover additive regression? Is that your question? I'll just make a note right now. Oh, what happened? Okay. All right. So, question is, right? No, actually, no. We'll have to plan some other session. Okay. Tomorrow we are going to start with deep learning, and tomorrow's session is open for all. It's a starting session. We'll cover basics of deep learning, basics of machine learning and deep learning, and we will then do the start with the hands-on tomorrow on the TensorFlow. Okay. So, all right. So we'll have to plan some other session to cover these topics, or maybe launch a separate course or something. We'll see what we can do. Okay. All right. Reinforcement learning will be covered in the deep learning session. Okay. All right. Reinforcement learning, what we will do is we will actually build a bot, as in there is a playground by the open AI, right? So there's a playground in case of deep learning. I'll just not note it here. Okay. So in case of deep learning, we have something called a playground. Okay. Which called open AI, and we'll basically code our agent who there are these gym. OpenAI's gym, actually you should take a look at the gym. So OpenAI provides a gym in which what it does is it basically is like a game. All right, so you give an input, it gives you feedback. You give an input, it gives you feedback. And so imagine there's a ball and you can push the ball, you can throw the ball, and so on, and it gives the feedback. So there are these classes which simulate the games, and your program has to play those games. Okay, so that is what we are going to use in case of the reinforcement learning. in the deep learning. So we'll try to build our own agent, which is going to play that game and master at it, similar to what we did in case of Mario demo. And if possible, we'll try to also see if we can build a Mario demo. But Mario demo would require a little bit more effort. And the existing Mario demos code is on Windows. And again, that would require a GPU. All right. So we are going to use, that's what we're going to use. This one is more predictable and easier to handle, and it helps us understand all kind of concept in reinforcement learning. All right. So that's one thing that we are going to do as part of deep learning. All right. So good. Now, for further resources, in case of knife base, you can take a look at these ones. Out of these, I find this one to be the most useful one. Okay. And right, so this one to be the most useful one. Rest is just standard. So and of course the Wikipedia. So this was a short session on knife base, and now we can start with the XGBoost. Okay, should we start the XGBoost? This is one thing that we had discussed in past. Okay, so all right. All right. So if you take a look at XGBoost, XGBoost has got a good website. I'm going to just interactively move back and forth between the tabs. Okay, so I'm going to open it in a separate tab so that I can switch it between. All right. Now, this is an interesting aspect of XGBoost. The XGBoost is basically really popular these days, and it's good that we are covering it. Okay, and so they have got their own website, and is actually kind of really useful useful tool, specifically for supervised learning. Okay, and this section is quite useful. Specifically, the slides by the author are quite useful. Okay, let me thank you, Binda. Let me also share the slides with all of you. Okay. It's the same slide, Binda, which we had shared in past. So just have reshared the link. All right. So this is Boosted Tree's homepage. Okay. And the slides that you see here is again interesting ones. Okay. These are the slides by the author. Now there was a very good link I wanted to show you there. Getting started, how to, and not this. Okay. All right. I was just trying to locate. There was a nice link where it showed that most of the competitions actually use the. All right. I'll share it with you. Okay, maybe towards the end there is one. All right. So XGBoost is essentially the further improvements over gradient boosting. What was gradient boosting again? Gradient boosting was okay. Let me just show you quickly if we can show gradient boosting. Gradient boosting essentially was this. Okay, so we do the first set of training. we predict something, we subtract the prediction. So we did the, here we are training one tree regression. Okay, all right. So I'm just giving a quick overview of gradient boosting. Gradient boosting was an ensembling algorithm in which we had decision trees, and what we were doing was decision trees is that we were first passing our data through one decision tree, getting the prediction, then we are training the second one based on the first one's prediction error, and then we continue the chain. So gradient boosting was essentially using multiple algorithms in a sequence being trained on the errors of the previous one. So if you sum up the predictions of all of the gradient boosted trees, then you will get the correct output, because the first one's predictions errors were being solved by the second one, and second one's prediction error were solved by third one, and so on. Okay, so so what gradient boosting is, what XGBoost is, extreme gradient boosting. Extreme gradient boosting meaning we take the gradient boosting algorithm and further optimize it. Okay, the author basically optimized the gradient boosting to another uh, another limit as such. Okay, so XGBoost it belongs to the same family as boosting algorithm that convert weak learners to strong learners. That's what boosting algorithm do, right? Ensembling or boosting does, correct? Weak learners into strong learners. So it is heavily optimized for, and it has optimized for distributed gradient boosting library. Again, so XGBoost has not only improved the base algorithm, but what they have done is they have created this independent library which can be used from all kinds of tools. Okay, you can use it in a distributed way, meaning it can be run on Yarn, it can be run on Spark, it can be run on many other systems. It can be run on EC2. So it can be run in a distributed fashion on multiple computers. Okay. Though we have tried to run it on CloudX Lab, it has not yet worked out. We will try to get it up and running. Okay. So XGBoost is used for supervised learning problems, and just like gradient boosting. So the inception of XGBoost was in early 2014, and it's basically a true love of Kaggle users. If you go to Kaggle, most of them would be using the XGBoost. Okay, and and then you will and basically it was created by the author in order to, and the author actually won one of the Kaggle competitions using this algorithm. Higgs boson, I think there was that competition, and it was created by Tianqi Chen, PhD student from University of Washington. So it has enabled parallel computing in itself using a framework called OpenMP, and by default it uses all the cores of your laptop or machine, and it has regularization. It has the biggest advantage of XGBoost is there are just too many parameters that you can regularize. Okay, as opposed to the normal gradient boosted models, which has not much regularization. Okay, number of leaps and depth is what we have at gradient boosted. That too comes from the descent tree under the hood. So other thing what XGBoost people did was, the author did was, since XGBoost was an independent library, right? And I'll explain this concept. I think this concept is useful. Okay. All right. So generally, let's say there is Python. Okay. and there is a C library. Okay, so let's say this is supposed to look like lib. Okay, let's say on the right hand side we have a algorithm called say XGBoost. Okay, right. On the right hand left hand side we have say Scikit learn, etc. Okay, the Python program. So from Python, every time you will be sending a data set, you'll be getting the results, right? So there is this translation, and we generally call it serialization. Okay, so whenever one language is calling the another one, there is a serialization effort, or we sometimes call it boxing, unboxing, and things like that. So we translate the raw translate one data frame into another data frame format and so on, right? Here we'll be passing capital X, which will get converted into something capital X form of the C library, right? So so there is always an overhead because of the border. Although the serialization, there has been a lot of work, but still there are this serialization is sometimes that takes more time. If the more interactions are there again and again, the more is the overhead. All right. So this is one of the reasons why frameworks like TensorFlow have come into play, because what we do is instead of doing back and forth between the library and the calling library, say Python. So instead of doing back and forth, what you do is you create the entire graph. You create a lot of steps, okay, and bundle them together as a graph, and then send it to the algorithm, and then algorithm gives you the results. So the one is this is called lazy execution. Okay, one way to solve it is lazy execution. The other way that has been very prominent is most of these algorithms, they tend to do a lot of things, and instead of we giving data back and forth, we give data uh, all of the data in a single shot and let algorithm do things for you. In case of XGBoost, in case of XGBoost, if we are doing cross validation ourselves, right, what we will do is we will create say 5 folds, right, create 5 folds, call this algorithm on one fold, then another fold, then another fold. So this way what would happen is there is a lot of back and forth, correct? So let's say we have a cross fold of 10, correct? So if we have cross validation and with folds equals to 10, there will be 10 such interactions, okay, for first fold, second fold, and third fold, and so on. So there will be 10 such interactions, and every time that the 10 times the data will be serializing. So what XGBoost has done is it has given us the support of cross validation, so that we'll just send the entire data and parameters instead of we ourselves breaking the data. Okay, we'll send the entire data and parameters to XGBoost, and XGBoost will internally do the creation of the folds and execution. So XGBoost has that cross-validation feature available out of the box. Okay, I hope this makes sense to you now, that what is the meaning of cross-validation when we already have Python cross-validation available to us. No? All right, give me some feedback. Did I make sense? All right. I think, yeah, I think everybody has gone to sleep or something. All right. Okay, let me repeat. So So remember how we did the cross validation? Let me just draw it again. I think this makes a lot of sense. And more and more these things would make more sense. So let's say in your program you have Python and you have C code, right? Right. So most of the algorithms are generally implemented in the C. Okay, that's or C, or we call them Python. There is Python, as in you write in Python, but when you compile it to C code. Okay, so all right. So why a good question, Kamal. Question is, why would it not make sense to just re-implement XGBoost in here? Because the C code is far more faster because of various reasons. While in case of Python, the code is generally a bit slower. Also, whether algorithm is being used in Java, Scala, XGBoost can be used from all kinds of wrappers. There are many, many more versions available than you can think. So, so there are many variants of XGBoost available. All of them are basically wrappers around the main library. Okay, so when we do the cross validation, what happens is, let's say we are creating three folds, right? So first fold, we got the answer. Second fold, we sent and we got the answer. Then we sent the third fold and we got the answer. Correct? So so from this border, whenever we are crossing this border, there is a serialization here. Okay, so there is a serialization at this time. Whenever we are converting one data structure into another, because these are the language boundaries. So we would end up with a lot of serialization overhead. Also, there are two right. There are two mechanisms here. There are two parts to it. The right. Let me put it this the other way. So when we are doing cross validation with three, right? So there are going to be three back and forth, right? So what XGBoost did was they implemented the XGBoost with the cross validation. So you only have to send data once instead of three times. Okay. Instead of three times, what you do is you actually just send it once we just make a call with CV equals 3, and we basically send X. Okay, so the XGBoost implemented. The other advantage is that XGBoost, just like we had, remember that just like we had these when we were doing ensembling, there were elements left on every sampling, and we were doing the testing on that. So XGBoost basically optimizes that cross-validation on the remaining elements. So basically, these are the two reasons why there is an internal cross-validation. Okay. A question from Vidya is, what is the function of serialization you just mentioned? Serialization is a part of the process. Whenever an object is crossing the boundary of one programming language going to another, it needs to be converted into the format that other programming language understands. Okay, so serialization is kind of inherent. All right. So did it make sense to you, Pavan? All right. Great, great. So that's one of the reasons. So I'm just trying to pay more attention to this part. Next is XGBoost is designed to handle missing values internally. So even if you don't need to pre-process data to handle the missing values. like we used the imputer, remember, where we substituted a missing value with median, or we deleted that column, or howsoever we wanted. Okay, so to handle the missing values, okay, to handle the missing values, you don't need to do extra step. XGBoost has inbuilt capability. With respect to flexibility, it can be used for solving regression, classification, and ranking problems. Okay, and it supports the user-defined objective functions. Okay, also you can define your own objective function. You can also define your own evaluation matrix, and it is available in R, Python, Java, Scala, and Julia. Okay, so also XGBoost provides its own loading mechanism of data and saving mechanism of data, and in an efficient format called data matrix. Correct. All right, a point from Bhavan. Rather than pushing data to the algorithm, we push the algo to the dataset, or parameters, I would say, and serialization effort will be less. Correct. Okay. Yeah. Serialization is translation of data format from one to another. Okay. Serialization is transformation of data format from one to another. And specifically, actually, serialization is a very important term. So whenever we have an object in memories, be it data frame, be it an object, be it a class, or be it anything, that object that you see need to be converted into something like zeros and ones. Okay, you need to convert those the objects into zeros and ones, a sequence of bits. Okay, sequence of bits. This is called serialization. Why is this required? To to transform the data from one border to another, like going from in memory to the disk, going from one computer to another, and so on. That's why the serialization is generally required. So whenever there is a boundary to be crossed, so you generally convert a complex object into something which is more generic, which is array of bytes. Okay, that's very common to all. Okay, all right, so this way. Great. Now coming, yeah. Okay, so yes, you can say that, Binta, binarization or serialization or interpretation. Yep. Okay, interpretation would be deserialization. Okay, when you have binary data, you want to interpret it and you want to construct something out of it. That's basically deserialization. All right. Now this is good. Now, so the other question that is rather than pushing data to algorithm, so instead of these three steps, we will basically do it only in one step. So it's kind of algorithm itself is handling the three parts. So the logic which was supposed to be this side for cross validation, the logic is moved here, and XGBoost already implements the logic. Okay, so it is that way. So I think Pavan is also right. All right. Okay. Great. Great. Now let's take a look at the Jupyter Notebook just to get an idea how it looks, and then we will talk about rest. Okay. A question from Pavan is, the way we do serialization for dataset, can't we do serialize an algorithm? That's what we do in case of distributed computing. But here, since we have an algorithm here, this algorithm is supposed to run really well in C. So it has been implemented in C as a different library. Though these programming languages can communicate, but whenever there is a communication out of the bar, there is always a translation overhead. Okay, that's how. So We do the deceleration of algorithm in case of distributed, but there it's a machine boundaries. Here it is internal process to process boundary. Okay, good, good. So even if we translated the algorithm from Python side to this side, the the algorithm wouldn't run as fast as the C code would run, and so on. All right. So moving ahead, let's take a look at our this one. Let me close this naive base. Bike problems is done. Here, if you take a look at which one are we going to, where is the, yeah, ensemble and the random forest. Okay, so I'm going to just go to take you over the XGBoost here. Okay, the good news is the XGBoost is available as part of the package, as part of the scikit-learn. So they have actually implemented really well the XGBoost in scikit-learn, just exactly on the same lines. All you need to do is differently. One, install XGBoost, right? That you can generally do pip install and XGBoost. Second, we can say from XGBoost import XGB classifier. Okay. Now this classifier's behavior is exactly like any other scikit-learns. Okay. The notebook is ensemble and random forest. Okay, that's a notebook. Okay, great. All right, so all right. So we have here is a very simple code. All we did different in this is use XGBoost and we imported the data. What we are going to do is we are going to use XGBoost on our MNIST data. So we basically loaded MNIST. Okay, then we picked X and Y from MNIST, like data and the target. Okay, the instances and the target. Now what we did was we basically shuffled the data set. After shuffling, we did this. Now here is an important part. So what I've done is here, since training this algorithm on 60,000 records is going to take long time, since training on 60,000 record is going to take a long time, what we have done is we have just picked 5,000 records, first 5,000 records from this data. Since data is shuffled, so it's okay to pick 5,000 records. And once we are done with that, then we initialize our XGB classifier and then fit the data into that XGBC classifier. Okay, so you can see that extreme boosted classifier is this. Next is we are going to compare the results of this one with the random forest and SGD classifier. Okay, so let me run it. Okay, and then this. So you can see that it is going to take some amount of time. That's the reason why we are just training it on 5,000. So XGB classifier is an aggressive algorithm. It takes time. And sometimes XGB classifier is also referred in the deep learning sessions because it is basically kind of multi-layered and it is used in the it uses GPU and distributed computing in parallel. That's why XGBC or XGB classifier is also called used kind of is also referenced in the deep learning. Now, this is taking some time. After that, let me just show you the rest of the part. So here we're doing the same thing what we've done here with the random forest and SGD classifier, and we're going to train these two algorithms after this. Let me also start this part. So it will automatically happen. Once that happens, once we have trained the extreme gradient boosting and random forest and stochastic gradient descent, once we have trained all the three algorithms, we three predictors, then we can three classifiers, then we can compute their scores using the test data set. Okay, once we are done with that, then we can train using we can test using the X test which we created earlier. All right. Okay, so we have trained it, and now let's try to predict. Okay, so you can see the accuracy. You can see the difference in accuracy. The accuracy of this one, Y predict, which is from Y predict is from XGB, right? And random forest is 0.88. So 0.91, 0.88, 0.83. 0.83 is of SGD, 0.88 is from random forest, and 0.91 is from XGB, right? So you can see that the performance of extreme gradient boosted tree is really high, really high. So performance of XGBoost is actually pretty good. Okay, it's 0.03 better than random forest and 0.08 better than the stochastic gradient descent. All right. All right. Similarly, we'll talk about the parameter tuning soon. Okay. All right. Is everybody ready for a bit of theory? So that's how the XGBoost work. Even if you don't get rest of the theory, you will be able to use XGBoost just like any other algorithm. And by hyperparameter optimization or random grid search, you can actually optimize your model. Okay, so should I go over some theory? Remember that the theory for XGBoost is a little bit more involving. The derivation is kind of multi-step. Okay, so I'm not going to go into the derivation much. I would basically go over like how does the algorithm looks like. If you want, I can explain the underlying algorithm as well. Okay, so it's basically further to what we have learned as part of gradient boosting. Okay, so the first thing is in case of gradient boosting or in case of any ensembling or boosting algorithms, what we do is we have many trees, right? We have many trees and many decision trees, and what we are doing is we are taking those trees and not only optimizing or growing those trees but also ensembling them. And essentially, individual tree is something that you need to optimize. Just like in case of linear regression, we optimize weights, W1, W2, W3, W4. In the same way here, we optimize individual trees because the end outcome is a function of all the trees. So you can see that the objective function in case of XGBoost is basically basically optimizing this predicted value. The objective function in case of XGBoost is optimizing this predicted value. And what is this predicted value? This predicted value is the summation of the value returned by the first function. And what's the function? Function is individual decision tree or individual tree. So individual tree returns us So individual tree returns us the value. We sum up the value, then we have another tree that returns gives us some value. We sum up all these values. That's our predicted value. Correct? In case of the gradient boosted trees, what we did was we trained the trees based on the residual from the previous prediction, right? In the similar way, we have here the predicted value is essentially sum of all the predictions done by all the decision trees. All right? Is this clear? Please keep asking because it's a very important point here that should I move ahead, should I go deep down or deep dive, or should I just talk with respect to objective? Okay, so let me explain the image. What does the image mean? Thank you, Abhinav. So here we have, let's say, two trees. What we do in case of gradient tree. So this is a tree, right? Here we have one, let's say two parameters. Okay, two parameters and one predicted value. So if the age is less than 50, go to this side. If age is greater than or equal to 50, go to this side, right? Then when it comes to this side, the average value of the leaf is -1, and that's what is returned. Okay, so this -1 that you see is the individual leaf's outcome. This is the weight, individual leaf that is giving us. Now, if you go to the left further, right? If it is male, then return +2, otherwise return 0.1. Correct? So what you see is here, what we are trying to do is we have a tree which does some prediction. The leaves do the prediction, remember? Leaves do the prediction because leaves are the one of which the value is returned. And leaves value is nothing but the average of all the values on that leaf. Okay, so we are trying to predict something like how many people, what is the chance of the people watching television. Then if it is lesser than this, then this, otherwise this. Okay, so similarly we might have another tree which has different criterias. It has split the data based on different criterias than the first one. Okay, so it has zero point 0.9 as the value on the left hand side, minus 0.9 on the right hand side. Okay, so basically, if you look at a tree, once the tree is formed, you can think of tree like a function in which you give a value to predict and it predicts some value. So individual tree is like a function. For example, if we are putting it here, a small boy, the outcome will be 2 plus 0.9, 2 from this tree and 0.9 from this tree. Okay, if you put an old man here as an input, the outcome will be -1 here and zero point 0.9 from here. So we have minus 1.9. So this is what the prediction is all about. Okay. So girl with the pink t-shirt, okay. So girl with the pink t-shirt will not be the input criteria here. It'll be girl with the age lesser than 15. So and the girl okay, and girl who is lesser than 15 years age and also using computers is not using computers daily. Okay, so if that is the characteristic, those are the what do you say, the features of the new instance. So that new instance's value will be 0.1 from here, right, and minus 0.9 from here. Okay, so 0.1 minus 0.9, it is 0.8 minus 0.8, correct. Okay, so because we have not splitted the tree based on the pink set, we have splitted the tree nodes based on use computer daily, age, and gender. All right. So I hope it's clear. So every tree behaves like a function to which you put an instance and it predicts the value. Okay, so the outcome is we take all the trees which we have created in past, feed the value, feed in the instance, and let's get the prediction from all of those, and then sum up all these predictions, and that is our y. That is our y. All right. Now, here the loss function. Okay, so this is our predicted value. What is the loss? Loss would be either root mean square error or mean square error or maybe mod absolute error and so on, right? So we will subtract this from actual, or we'll compare this with the actual and using some kind of loss function. Here L represents loss function. It could be mean error, it could be anything. So we are saying that our objective is to minimize this loss. To minimize this loss plus a regularization term. Remember the ridge regression where we added weights, right? In the same way, we are going to add the weights here. So we have objective function as two parts. One is the actual error or actual loss. Second is the regularization element. Okay, is this clear? Okay, so Kamal's question is, can you highlight the difference between XGBoost and random forest? Random forest was actually basically picking up random decision trees and optimizing them. Here it's doing it very strategically. The other biggest difference here in case of XGBoost is it has a big regularization term. It has a big regularization term. Random forest was doing the regularization by the way of just using the multiple decision trees, and finding the average of that. Okay, so finding the kind of removing those overfitting by the way of having many decision trees. Here, it explicitly adds a regularization term. Okay, this regularization term is a function of all the trees. It's a function of all the trees. So is this objective function clear to everybody? Loss made by first tree plus loss made by second tree, loss made by third tree, and so on. What is the loss? Loss is error between the prediction and the predicted value. Actual and predicted value. So this loss is the difference between actual, yi is actual, yi cap is predicted value. So this is basically that loss. Okay, a question from Kamal, but here we are also finding the average in the similar way. Correct. In the beginning, we are starting from the similar way, right? We are starting from the similar way. We are starting with similar as gradient boost. Here this loss is decreasing, right? Because there is an actual value. We did the prediction. Then whatever is the delta, we feed that delta to the next tree and so on. So here also it's the same way. Okay, here also same as gradient boosting. Now, so you got the objective term has got the two parts. One is the loss and other is regularization term, right? Here the y predicted is a function of f, while in case of the linear regression, the y predicted is a function of w's, right? And therefore, in the linear regression or ridge regression, we did the regularization based on w's. Remember, there was a factor called w. We did that. Correct. So this is the objective function. This is the actual loss function. This is the regularization term. Actual loss function is basically the summation of all the functions, all the losses. Okay. So this is the actual loss function, as in summation of all the losses. All the losses are function of all the trees, summation of all the trees, and so on, right? And this regularization term is further defined it here. Some coefficient multiplied by total number of leaves plus 1 by 2 lambda into the weights of individual leaves. Okay, so what it does is these values that you see here, these are called weights. Okay, so just like linear regression, it puts the weights on the it basically puts a term which is which is basically controlling the freedom of the weights. All right, so this is what it is doing. So I think it is putting yeah, these weights are for individual leaves. So I think it is assigning some weights extra other than the actual predicted value. Those are the ones it is calling the weights. Okay, so what it is doing is it's controlling the number of leaves. T is total number of leaves, and for each leaf, what is the weight? So it's basically summing it up. So trying to minimize the weight of individual leaves, as well as it is trying to control the total number of leaves. Okay. So objective function of XGBoost tree is made up of two parts. One is the predicted values, other is the regularization term. All right, and when you combine all of this together, this is the objective function you get. Okay, what are these terms? Basically, it uses it's a full derivation is quite huge. Okay, so this is the objective function of XGBoost tree. Okay, what it does is it sums up over all the leaves. For each leaf, it computes Gj. For each leaf, it computes capital G square G square divided by capital H plus lambda plus Y into T. Okay, every time on every leaf, this is what it does. It computes this objective function. And how does it compute the capital G? Capital G is summation of all the small g per leaf. And what is small g? Small g is first derivative of loss function. First derivative with respect to predicted value yi. So y minus yi whole square, that is the derivative. Okay, so gi is first derivative of the loss function, hi is the second derivative of the loss function, and if you sum up all these gi and hi for each leaf, then you'll get gj and hj. Yeah, all right, so that's how the objective function is. So all it does is it control in this objective function, what it does is it tries to create the trees while controlling the number of leaves, while controlling the lambda. Lambda is what? Lambda is controlling the weights of each tree. Yes. Question from Kamal is, should we read the objective function as to minimize the right hand side? That's right. Objective function to be minimized. These both the things, losses need to be minimized, and the weights of and the sigma needs to be minimized. Sigma is nothing but number of leaves plus weights of each of the leaves. This need to be minimized. So essentially this is the objective function that XGBoost tries to minimize while creating the trees. Okay, and it does quite a much things. It also does heavy optimizations, such that instead of thinking about the additional weightage of individual leaf, what it does is it computes the overall weightage and then goes up. I'll go into that part. If you are interested in going into derivation, you must take a look at this one. It basically, this is where it starts. This is the objective function, loss function plus regularization term. Loss function could be one of this, but it can be passed by the user also. So that's why loss function could be anything. This was the loss function in case of linear regression. This was the case of loss function in case of logistic regression, and so on. Here it talks about regularization and so on. So Here it talks about tree ensemble, like what is the purpose of individual the tree and how does it work and so on. Then he talks about here the yi is the function of function is a summation of all the functions and so on. Then what he does is he basically derives further, and I can actually explain to you the entire algorithm, but okay, but that will take a lot of time. So if you want, I can keep one-on-one session or something like that in order to explain. But going into the derivation is not something that uh, would help much. But for your self-interest, you can try that. Okay. All right. So that was quick introduction of XGBoost. Let me just go into. So now the as you can see clearly that there are multiple parameters in XGBoost. Number of leaves, T, lambda, and then gi and hj. These are not hyperparameters, but they are basically the function of loss function. Okay, so whatever we learned for trees, those hyperparameters would remain, like number of leaf per node, max depth, and so on. Additionally, we have these many more parameters. So again, parameter tuning is a dark art in machine learning. The optimal parameters of a model can depend on many scenarios. So it is possible to create a comprehensive guide. It is impossible to create comprehensive guide for doing so. Okay. Again, all of the parameter tuning is all about bias versus variance trade-off. Most parameters in XGBoost are about bias versus trade-off. So on the left-hand side, you see bias. So bias is also called a simple model. When you have simple model, okay, when we allow the model to become more complicated, the bias would increase. If you have really simple model, the bias will be high. Or when we have simple model, you might underfit, as in you could draw a single straight line instead of you might try to fit a straight line in the parabola. That's underfitting. The overfitting is variance, as in the better ability to memorize or fit the data, and performs bad on training and testing data set. So when you have more bias in algorithm, the performance on training as well as test data is bad. While in case of variance, it performs really good in case of training data, the instances that it has memorized, and it does not perform on the testing data set. Okay, so I hope this is clear to everybody. Now, how can you control the overfitting? There are two ways you can control the overfitting in XGBoost. One is directly controlling the max depth. Max depth is the max depth of each child. So the more depth you have in the tree, the more it is going to overfit the data. Minimum child weight, as in if you have minimum child weight at 0, then what it'll do is it'll keep on going till the point where it has created the whole tree. So it has created one leaf per node. Therefore, it is important to increase the minimum child weight. Then there is gamma. What is gamma? Let me go back to the diagram. Gamma is this. Okay, more gamma means more regularization in terms of the leaf. Okay, in terms of the leaf. So basically, the regularization, uh, if you increase gamma, the number of leaves will be lesser, because if you increase gamma, the impact of t, number of leaves, is going to be more on the objective function, and hence the objective function will try to decrease t in order to bring the impact of gamma lower. Okay, so again, this objective function, we could actually see that, imagine that we have a tree here. For each node, for each of the leaf, we have these I1, I2, I3, I4. Okay, I1, I2, I3. I3 has 2, 3, 5, 2, 3, 5, and I2 has 4, and I1 has 1. So if you have this kind of a tree in which the various users, So you compute the small g and hi, as in the loss for each node, and then you compute the capital G by summing up all the losses for each node. Okay, losses, first derivative of losses, second derivative of losses. Okay, and then once we are done with computation of capital the capital G and H, then we compute this. Okay, we compute this. All right, so that's basically the objective formula. So back to the overfitting. So we add randomness to make the training robust to the noise. Okay, this includes subsample, this includes column sample, per binary tree, and so on. Okay, and we can also reduce step size. There is something called step size because every time we are training a tree, then there is another tree that we are creating. Instead of just summing up them in a straight way, we multiply the new f with an eta, with an eta. Okay, so it needs to increase. Also, we can also, if we have decreasing the impact of the new trees, we are say reducing the eta. Eta is the learning rate. Okay, then we need to increase the number of rounds. Okay, when you can do so. So this is basically a very simple way of looking at parameter tuning. So you can keep this in mind when you want to increase the depth. That's overfitting. Then increasing the child weight, decreasing the again minimum child weight. If you decrease that, they'll start overfitting. Similarly, the gamma, if you decrease gamma, the number of leaves will keep on right. If you decrease gamma, then it would have more and more number of leaves and essentially would overfit. Okay, so there is no single rule for overfitting, right? Although there is this guide I have written, but I'm not really convinced that you can actually learn and decide based on this guide. Okay, I'll just give an overview. So XGBoost can be used either with the tree, decision tree, or it could be used for linear models. But mostly it is used for tree because in linear models, it doesn't give you as much performance as it gives in the trees. Okay, so it generally, there is another parameter called silent. This is for logging the debugging messages. Then number of threads. By default, it consumes all the CPUs. Okay, but you can reduce if you want to by using nthread. Then we have learning rate, min child weight. Then we have gamma, then we have a max delta step, and so on. So these are the various parameters. So there is no straight answer. One easier way is that you just start with the default one, and and then you basically do the grid search. Okay, grid search by if you observe whether your model is performing bad on training or testing data, and then see if it is that will help you understand whether your model is overfitting or underfitting. Okay, that would help you decide. All right, so these are other parameters. One more thing is that here is an example of how to use grid search. This we have already used. Okay, so this you can see in the notebook. Also, here are some of the examples that I've taken. One of the examples that I've taken from one very good performing Kaggle tuning. Okay, so there is this user who has P Hunter who has uh, used XGBoost and has won a couple of competitions. So he says that we should keep max depth between 6, 7, 8, learning rate around 0.05, but we can make small changes to learning rate. But if you are changing that, we'll have to increase the number of iterations. Okay, so then we have other parameters. So you take a look at this. That should give you a better idea. Okay, for further these links I've already shared with you. You can try to go through this one. Also, you can read through these links. A question from Noor is, for 5,000 records, it took a bit of time, but if we do grid search, then how long will it take? Correct. It is going to take some time, and that's why on our servers we have around 4 cores. But if you have GPU machines, it can if you have GPU machines that it can actually perform really well. Okay, it can really perform well. Okay, great. So that was about XGBoost. So all right. So we did not get, I think what we'll do is, I think I like to take this natural language processing in more hands-on way. I will schedule one session for uh, supervised learning with NLP. Okay, what if your data has NLP, natural language data, and you want to perform the end-to-end project that we did earlier? That's one project I'm planning to schedule. We'll go through that. Second is the unsupervised learning, supervised learning, uh, and with NLP. So examples are say NLP, NER, we call it, named entity recognition, and we will also talk about the various libraries. So this is something that we will, I'll email you soon. We'll schedule it week, over the week sometime. The NLP part is kind of due. Okay, we already have NLP topics here, which are there. Okay, so if you want, you can go over it. We have also created Jupyter notebooks in our repository, so you could use those. Okay, I'll just give you the slides. Okay, slides are confidential, so if yeah, right, sharing with somebody, let us know. Okay, that'll be better. All right. Great. So that was pretty much with the natural language processing, and we will also okay, no, we will also talk about NLP in the deep learning. Okay, in the deep learning, specifically with the tools like LSTM or RNN. Okay, we'll talk about deep learning there also. We'll do one exercise there. Okay. All right, so tomorrow is a free session on the deep learning. Come over, all of you. I look forward to see you in the deep learning session at the same time. And today is officially the last day for the course. We will be putting more exercises, and we will be in the meantime, you try to solve these projects that we have posted there, and stay connected. Stay connected. I look forward to see you. Feel free to send me a LinkedIn request. Stay connected. The relationship with CloudX Lab is not only during the course. Once you are a student of CloudX Lab, you will be uh, getting updates from our side. We will be connecting you for the project. Okay, and the audio project, I think. So whoever is interested in audio project, please do let us know. You can just let me know now. I can just connect. Yes, you are a family now. That's a better way to put it. Okay. And can we start a Slack channel? Yes, definitely we can start a Slack channel. Okay. Okay. Slack channel. All right. Let me just plan a Slack channel. That'll be a good idea. Just that I find it very uncomfortable with Slack channel. Okay, I think discussion forum is good. So Kamal was suggesting that we should actually post on discussion forum. It is more searchable, and it's more people can respond there. Okay, and okay, so come over to discussion forum, and I'll be also more active there. Abhinav is quite active, and other people are quite active on the discussion forum. So come over and yeah, contribute to I mean, try answering other people's question also. That would help you also learn. And okay, a question is how to submit a project. And these two questions are very important. So those who are interested in working on audio project, it's around 1 GB of data. It's around 1 GB of data we have got from the audio studio. Okay, so I'll just tell you what it is. So there is this, so there is an audio studio. What they do is people go there, record the voice, and once the voice is recorded, the the audio engineer sits on the audio and then removes the sound of the breathing, sound of say lip smacking, or say and ahs, and there is a gap between the talk. So all of these things are cleaned by the audio engineer manually. So if there is a recording of 2 hours, it takes around 4 hours to just clean up the audio. Okay. And it's a very frequent task for many people. So what I thought is that since he is since he is anyway mm, having all of the data, the unprocessed and processed one. So I had asked the audio studio person to send me the somebody else's recording. So most of the audio is confidential. Okay, I'll just send you a small email in which you just reply saying I agree. That means you are agreeing with the confidentiality thing. And so I was thinking that we could take that 1 GB of data and see if we can use our existing learning to clean up that data. Remember our image cleaning exercise where we took an image, made it dirty by throwing pixels on it, and then we used the classification to clean it up. So I was thinking that we could do a similar mechanism, or we could come up with more strategies to clean up that data, because most of the data set that we see over the Kaggle or here and there, they are basically cleaned up data sets and well-defined problems. But when we come to the reality, like I was working with this recently, a project from uh, this Tribo, as in the hotel booking guys. So there, the kind of emails that he gave me was very unstructured, and it wasn't really something that is that basically you will spend a lot of time in just pre-processing, and that's the reality. So we must learn that art of solving real problems with machine learning. That's why I basically requested the audio studio guy to give us some audio data. All right. So who all will be part of this project? Just raise your hand. I'll just send an email introducing all of you in the email. Or if you want, I can just put everybody in the CC and then we can connect. Okay. So I'll just connect to everyone. All right. So and we'll start. The thing is that we need to be a little more aggressive. So I have put Kamal in charge of that project because Kamal is living near to the audio studio, the same guy. So he can generally, if we need more data, he can coordinate with the audio guy, as well as so so okay. All right. So yeah, we can start on that. Okay. And the other project that I was talking about is the music one. Okay, that one also I'm going to confirm maybe in couple of days. Okay, so I'm talking to this musician, the musician who is working on the prediction of audio. So that project might also be coming. Okay, so that doesn't mean that, right, that we can all participate and so on. All right, so I'm not charging anything for anybody for the project. We are doing it for our own sake. Okay, yeah. Okay, question from Noor: we can have a workspace exclusive to these projects. That's right. That's right. We can just create a folder, create a group, add all of the people in that group on in our Unix, and I think that'll be a good idea. Okay, we'll do that. All right, this is a good idea. Okay, all right, so I will do that. I'll do that. Okay, cool, great, wonderful to have all of you in the session. Okay, a question from Kamal is, but can we do collaboration on the notebook? It's hard actually. It's hard to do the collaboration on the notebook. So instead, we can just use the use GitHub as collaboration tool. Okay, between multiple people. The way we do the collaboration of the notebooks. All right, great, great. All right, so see you tomorrow. All of you are welcome to the session on the deep learning. I look forward to go in detail. Okay. All right. A question from Kamal is, why not Google Colab? Because there will be these data uploading issues. Okay. Thank you, Balaji. Very happy to know that you found the sessions excellent. And all right. Okay, so great. The deadline of the project. Okay, so we generally the deadline of the project is supposed to be like 15 days from the last day. Last day is today. So 15 days from today will be the deadline for the project. It'll be better that we go over that. So, okay, so deadline is 15 days. Audio project, we have not finalized the deadline. We'll first take a look at the data and then we'll decide on how much time will it take. Okay, so 15 days from today. All right, great, great. Wonderful to have all of you in the session. Thank you, everyone. Have a good day. Thank you, Ross. Thank you, Noor. Thank you, Kamal. Thank you, Gigi. Thank you, Bintao. Good set of questions. Thank you, Balaji. Great. Thank you, everyone, for a great session. As always, it's a learning for all of us. Okay. And I also learn few things every time I teach. All right. Thank you, Kamal. So Kamal thinks that it has been an awesome journey so far. Great, great. I have been also had a really good time in this class specifically because most of you are really, really good at the logic and the computing. Okay, so great. I look forward to see you tomorrow. Bye-bye. Have a good day. Thank you, Ross. Thank you, everyone.